It's Thursday, and our contractor, Jay, has had his crew here for about half the day, and this is the afternoon, so they've left to go to another job, small job that he says that they have to work on, and I'd like to show you what they were actually doing in preparation for what we are hoping is the arrival of the joists to be placed at the top of the first floor tomorrow. So here you can actually see the supports for the scaffolding, and there you see the underlying parts to them, and the wall supports that were holding up the walls while the concrete was being poured in them. And here are the connectors that hold the scaffolding together. And so some of the scaffolding has been taken down, and here in the garage you can see primarily it's been taken down on the outside wall there, so there's no longer any scaffolding holding up that particular wall. It's still here because they're going to be doing the majority of work on the joists across from the front to the back of the actual garage itself. And in this little location they'll be, I don't know exactly how they're going to be doing that, but I suppose that there's probably some kind of hanger that's going to be attached to that plate that you see at the top of the wall there to the outside wall at some point. And what the plan is that Jay wants to actually finish off the garage, get the membrane up, make sure that the entire garage is watertight, so that we can, and probably boards in the place of where the garage doors are going to go and the windows, etc., so that we can actually place a heater in here. We've got electricity on the site, and get this warm and move the rest of the ICF blocks into the garage so that we can use it as staging for the next stage of the build, i.e. going to the second floor and to the roof, which should occur within the next 2 weeks or so. But we're already starting to have indications that the weather is turning away from us. One of the other things that I did not do is have a description, an explanation as to why we are using this particular building method, and what the advantages are, etc. One of the main advantages are that we use very little of this stuff, i.e. the wood. The only wood that we've actually used is for the top plates up there, around the windows and the doors, and as shoring. But all that shoring for the pouring of the actual concrete is just temporary. It's been used before and it'll be used again. So it actually is not part of the overall expenses of the house itself. And you'll see in the main house, the only wood that we've got is internal. Again, the ledger plates, etc. So let's go back to the ICF way of doing things. We are building essentially what could be considered very, very close to being a passive house, meaning that you don't have to have the addition of large amounts of energy to keep it warm in the winter and cold or cooler in the summertime. It's so very well insulated, and you can actually see that in terms of the width of the walls. So if you take a look at this outside wall, for instance, you have the width of the wall from here to here, so that's what, a 12-inch or a 14-inch piece of wood. And then we're going to have another 8-inch section that's going to go to the outside of that metal plate. That's called a thermal wall. That's going to envelop the entire house, so that you will end up with the better part of I think 23 inches or something along those lines from the inside to the outside of the thermal wall of insulation. So you of course are aware that this is not all insulation. There are a mixture of things. So if this is the inside wall consists of styrofoam, so about 2 inches of styrofoam insulation. Then we have the center cavity. The center cavity is where all of the concrete ends up going. It goes inside and it creates this complete wall in the center space. And then you have on the outside, again, another 2 inches of styrofoam. And then that other 8 inches of thermal wall that's going to go outside of this. Basically, the idea is that it's going to be very, very sturdy and no wood, remember, and very well insulated so that any of the outside temperature changes won't necessarily be reflected in the interior of the actual household itself. Another feature of the way that we've constructed our floor, and I have mentioned this before and you saw it earlier, that the entire concrete floor is built up on a base of styrofoam as well. So if we go to the outside, you can see that there's, at the ground level, there is, so here's the ground level. There is a section of styrofoam. Then we've got another section of styrofoam. So we're looking at probably about 2 feet again of styrofoam upon which the concrete is actually formed. So here you see the concrete inside, the styrofoam outside itself. We'll end up with some skirting on the outside, and then it's all going to be covered with topsoil and other kinds of aggregates to make sure that things don't get wet. Where else are we going? In the floor is a series of pipes that are all coming to and going from this particular location here. Doesn't look like much at this point, but all you're seeing is some concrete sitting on top of plastic, which is hiding the metal manifold. So a section that has all kinds of pipes coming out of it. It also has a fan in it, and it has a heating element. So what we've got essentially here is the equivalent of a pretty big hairdryer, if you want. It is going to take a certain number of wattage. I don't know exactly how much power it's actually going to take to actually drive the entire unit, but the idea would be that you would heat up the entire concrete floor and get it to a stable temperature. And keep in mind that there's a number of inches of concrete here so that it becomes essentially a heat sink. So once it gets to temperature, it'll hold that temperature for a long period of time because there's a lot of mass here, a lot of stuff. Going back to my chemistry teaching days, there's a lot of mass that is going to hold on to the heat, the energy that we're putting into it through air and the pipes that are going to be conducting it all the way around the house. And so that heat during the winter is going to radiate up from the floor and through the rest of the house because heat rises as it's released, as it radiates. And during the summer, we'll be taking as much of that heat as possible and putting it back into the floor itself so that the floor acts as a heat sink or a heat trap during the warmer parts of the year, and during the colder parts of the year, it's going to be radiating that heat back to us. So that should mean that we need to spend very little money on energy to heat the house. We're told that this kind of a building once it's finished, and we'll have triple pane glasses, windows for all of the windows, very, very heat efficient all the way around. It should come out to the equivalent of about net zero, i.e. you'll have to put in very little energy to be able to actually maintain the house itself. So we hopefully won't have to pay any energy costs above what our actual inputs are. And we're hoping originally, or to initially, deal with what is called net metering. So there's our hydro hookup there. It's got a switch on it so that we can break the connection to the net, to the hydro lines whenever we want, rather than having to wait for Ontario Hydro to do it. And we can install our own solar system on the roof of the house when it's finished. And we essentially can do net metering, which allows us to use our own solar power, but anything that's above the use that we actually have is going to be put back into the grid. So it goes back into the power lines that you see in the background. And we'll be given a credit for that by Ontario Hydro. And at the end of the year, hopefully we're making money off of our energy production rather than paying money to Ontario Hydro to heat the house and to keep it lit and run the computers and all those kinds of things. So the idea is to be as energy sufficient as possible, autonomous, not reliant upon the grid, and eventually we'll get to the point where we're actually going to fill this utility room that's starting to take shape here with batteries, etc., so that we can disconnect our connection to the network and run off of our own energy production. At least that's the plan. And then we'll be producing as much food as we possibly can from the gardens as well. So the idea there would be that we're going to be autonomous in terms of the food production, and hopefully we'll put some chickens in the backyard there at some point in the future, and again get to the point where we can supply as much of our own needs as we possibly can get away with, so that we're reducing our carbon footprint and simultaneously giving a model for the way that houses could be built here in Canada, so that we are not viewed as being one of those energy consumption countries as we are at this point in time. Anyhow, I'll leave it at that point. Just a couple of points about where we stopped yesterday. So all of the hangers are in place now on that particular wall. There's still no ledger board there up in the corner, but there's still 2 hangers up there, so I assume that they'll do that at some point soon, because they've done it up here, so I'm not sure why they're hanging on to that particular location. Hangers are here, hangers all the way across the backboard. And yesterday I made some allusions to it, but here is the connector between the back wall and to our bearing wall. And then there's another one there doing exactly the same thing. Why they've continued to leave those, I don't know. And this board here, this 2x6, and this set of boards here and here will eventually be taken down as well. So I think those are just temporary while they're putting up the actual bearing wall. So the joists will be hanging from those joist hangers, and will be sitting on top of that bearing wall. And from the other side, you've got exactly the same thing happening. So a joist goes from that south wall and sits on top of the bearing wall there. And so you end up with two sections of the house. This section of the house, the south side, the south facing side, will end up being quite a bit higher at the peak. So right at this wall, if you go all the way up through the second floor, which will also have a bearing wall on it, it'll actually end up being about 26 feet in total. Whereas this side will end up being 22 or 23 feet in height. So two different heights depending on which side of the bearing wall that you're actually on. I'll take a look and give you an insight to the plans that we've actually drawn up. They've all been well documented. We've got them laminated, and I think I'll do a special at some point just walking through the plans so you see the gist of the ideas that we've actually been able to put together in the plans themselves, and how they're being implemented or come into reality in terms of the actual building itself. And I'll give you a little bit more information about the philosophy that we're going into this with, and the hopes that we actually have for the space, the house, how it's going to actually allow us to move forward in terms of our thinking about conservation and providing a kind of answer, a set of answers to the climate challenge crisis that we have in front of us, and what we hope to do to be able to actually show people a different way of life than what you'll see in terms of what's going on over there. So very, very traditional construction that you'll see in that garage, driving shed, barn, whatever it is. And even the kind of construction that we've got from our neighbors beside us and the other house that's in behind us. So taking a look at how different this is and the kind of benefits that you actually get as a consequence. I'll leave it there and talk to you again soon. Hopefully tomorrow when we see the joists showing up. Let's cross our fingers. Talk to you later.